So as you can see this evening or morning, whichever it is for you all, that's the beauty of online lectures, right? Um, we are going to go ahead and dive into the chapter on blood. So, oh yes, let me go ahead and start my presentation for you. Oh yes, there will be blood. So just to make it fun for my first slide here. We are going to dive into how amazing your blood is as part of the cardiovascular system. So let me go ahead and just start by talking about, oh, and I'm going to go ahead, I have my video on just so that you can see me. I'll kind of turn it on and off if for some reason I need it, but I'll turn it off right now because I'm probably in part of the way of the screen right now. So and I'm going to go ahead and take my video and move it out of my way here. But anyway, so you can see when we initially talk about the body, there are these two major fluids of the body. And so cells of the body are serviced by these two major fluids. And so, of course, one is blood, right? It's the easy one that everyone can kind of come up with. And so blood, again, is going to be contained within your vessels. But then there's the second fluid called the interstitial fluid. And that interstitial fluid is going to be the fluid that's going to bathe the cells of the body. So both fluids, again, are very important for the functioning, the overall functioning of the human body. And so when we talk about blood, we'll get into the fact that, it's composed of plasma, which is what carries the majority of your water. Most of plasma is made up of water, and a variety of cells. So red blood cells, you can probably guess, white blood cells, thrombocytes, which are platelets. And the main function of your blood is simply just to transport things like nutrients and gases like oxygen and even wastes like carbon dioxide throughout the body. And again, it will transport those things like nutrients and oxygen to your tissues, okay, throughout the body, to the tissue throughout your body, through this interstitial fluid that bathes all of our cells. So that's how these fluids of the body are kind of connected, and kind of interesting when things go wrong, like you have something like elephantitis, and you end up basically having too much interstitial fluid, then you see things like this extreme edema. So anyway, just I had that picture to kind of help you understand what interstitial fluid was, because it's easy to picture the fluid that's surrounding your cells in the kind of extreme end where someone has the edema because they have too much interstitial fluid. And so the poor individuals with elephantitis are a good example of that. So again, we just kind of talked about this. Fluids of the body, again, the cells of the body are serviced by these two major fluids: blood, which we talked about and talked about some of the functions, and then the interstitial fluid, the fluid that bathes or surrounds the cells of the body. And again, nutrients, we talked a little bit about this. So nutrients and oxygen are going to diffuse from the blood into the interstitial fluid and then into your tissues, into the cells of your tissues. So the interstitial fluid is an important fluid that we don't really ever talk that much about sometimes, but it doesn't get a whole lot of credit, but it's equally as important, because you couldn't get those nutrients, you couldn't get those oxygen, the waste products into the cells without the interstitial fluid. And then, of course, again, wastes will just move in the reverse direction from the interstitial fluid into the blood. So then they can be carried to places like, again, the kidneys, the skin, places that are going to excrete those wastes. So hematology is actually the formal term for what we call the study of blood and also blood disorders. So just kind of a little terminology there for you at the end. So really quick, let's talk about some of these functions of blood. Obviously, it's easy to picture blood and the function of transportation. So you probably know that blood, here's my funny little diagram for that blood carries oxygen to your tissues, right? You probably also know that it carries carbon dioxide away from your tissues as a waste product. So again, transporting things like oxygen, carbon dioxide, other metabolic wastes, right, away from the tissues into places where it can be excreted, like the kidneys and the liver. But then also transporting nutrients. So our blood is important for transporting nutrients that we're absorbing, right, through the GI tract, and then transporting those nutrients to the tissues throughout the body. And then it can also transport things like heat and hormones as well. Hormones are going to travel through your bloodstream. So again, that's one of the main functions. The first main function of blood is transportation. The second main function of blood is for regulation. So I don't have a cool diagram for it, but pH does help to regulate, or blood does help to regulate pH. It actually regulates pH through these series of buffers that we're actually going to end up talking about a little bit later in another lecture here. And then it's also going to help to regulate our body temperature. And it's going to do that in two ways. One, the fact that blood is mostly made up of water helps to regulate your body temperature. And that's because, here my lovely picture, water has a really high heat capacity, right? So it takes a lot of energy to change the temperature of water and therefore to change, again, the temperature of your blood. So that's one of the ways in which it can regulate your body temperature, is simply by almost even having this kind of coolant property of water, in that it takes a lot of heat to increase the temperature of your blood. So then it can also help to regulate your body temperature by just some simple physiological changes, right? So you can end up having something called vasodilation if you're really hot, and that will bring those blood vessels to the surface so that you can actually lose more heat as those blood vessels dilate from the body, from the blood. So you're actually losing more heat. And then, of course, if you're cold, then those blood vessels are going to constrict, called vasoconstriction, and that will help to prevent heat loss as you pull those blood vessels away from the surface. So again, vasodilation of surface vessels can actually dump or get rid of heat, but then vasoconstriction of those vessels can actually help to hold in heat as well. And then you also have this regulatory function with blood, in that it helps to regulate the water content of cells in our body. And it does that through this blood osmotic pressure. So it has its own osmotic pressure so that blood doesn't lose too much of its liquid via osmosis to the interstitial fluids, but then it also doesn't keep too much of that. So it has this nice balance where and we'll talk about kind of a little bit more about how this works, but when we get into talking a little bit more about blood osmotic pressure. But this becomes very important for all kinds of regulatory functions, and we'll talk quite a bit about this with the kidneys when we get to that as well. And then we also have this third major function of blood, and that is protection from disease and also the loss of blood. So I came back to this little diagram because here you can see the little white blood cell, right? And there's the white blood cell chasing off a bacterium here. So again, that's your protection from disease and infection, right? So you've got your white blood cells in your blood that are able to do that. But then you also have the ability to actually protect against the loss of blood. So within the blood itself, which is kind of cool. So it's a built-in safety mechanism here with platelets, or thrombocytes is the more formal name for that. So your thrombocytes or platelets can actually help to prevent blood loss, forming a platelet plug, and then there's a whole process on eventually repairing that blood vessel. So just kind of interesting in terms of those main functions. So here, this is kind of all of what I talked about, just in words for you, so that you have it for your notes. So three major functions, again, transportation, regulation, and then protection from disease and loss of blood. So let's get into some actual physical characteristics of blood. So I'm sure many of you know these, but just in case you don't, blood, of course, is thicker than water. The term, blood is thicker than water. It really is. Not just a colloquial saying, but it really is. Blood really is thicker than water, and then it's more viscous. And so it's going to flow more slowly than water is. The temperature of blood, on average, is about 1 degree Celsius higher than like your oral or rectal body temperatures that you're going to take. And so if you look at the temperature of blood, it's usually about 100.4 degrees Fahrenheit or about 38 degrees Celsius. Again, you probably know about average is 37 degrees Celsius when you're taking your temperature either orally. Hopefully, if you have a little one, you have to do it rectally sometimes, but not the most pleasant. I have kids, but you try to always do it orally, or now they have the temporal scanners, all that. pH. So blood pH is about 7.4, so just slightly alkaline, very slightly, right? But pretty much, for the most part, pH 7 is neutral, pretty close to neutral. Again, on average, your blood makes up about 8% of your total body weight. And then this is where it always gets interesting. Your blood volume in males is slightly larger. You have about 5 to 6 liters in the average male, and then about 4 to 5 liters in the average female. And we'll talk a little bit more about this a little later, about how this is maintained by hormones. So let's real quick get into the components of blood. So what makes up blood? So if you were, excuse me, to take a tube of your own blood and to separate it out, and the way in which you would do that is using a centrifuge. So centrifugation, as you probably know, will, using, of course, centrifugal force, will force the heavier formed elements to pack down more at the bottom, and the less dense elements, which would be your plasma, to remain up top. So again, if you were to do something called a hematocrit, you end up taking your blood and putting it in this tiny tube, which actually I'll show you here. And then you put it in a centrifuge. And what you're going to end up finding out is that all of your formed elements, which are going to be your cells, are going to be forced to the bottom. And again, your less dense plasma will remain up top. So when you look at an average hematocrit, and you were to look at this as, 100% here, about 55% of when you separate out your blood will be plasma. So about 55% is going to be plasma. And then the other 45% here will be cells. So here's all the cells from this line down, including the buffy coat. And when you take those cells, and that's where I'm going to kind of switch over and do this diagram here. So again, you've got about 55% plasma and 45% formed elements. Now, if you were to just look at these cells here, you're going to see that you can break up your formed elements into what's about 99% red blood cells. So the majority of your cells, of your formed elements, are going to be red blood cells, or erythrocytes, we'll more formally call them, coming up here. And then less than 1%, of your formed elements is going to be your leukocytes, or white blood cells. So again, more formally, we call white blood cells leukocytes. And then thrombocytes as well, so platelets or thrombocytes. So again, that's less than 1% is going to be your white blood cells and platelets, or again, your leukocytes and thrombocytes. So that is the breakdown for, and when we're talking about, again, your hematocrit, we're kind of breaking out what percentage is your formed elements. Now, when you look at the plasma section, just to kind of go over this really quickly, and we'll talk more about it again as we delve into the lecture a little deeper, but blood plasma is not just water. So the majority of it is water, so about 91.5% of it is water, but then this other portion that, again, smaller but equally as important, are your proteins. So you have about 7% proteins, and some of these proteins are albumins. So the vast majority of your proteins are albumins, and we'll talk about those in terms of helping to regulate blood osmotic pressure. They're really important for that. We'll talk about your globulins, which also you have, large percent here is globulins. So those are going to be things that are important in terms of like your immunoglobulins, your antibodies. So important immune functions there. And then fibrinogen, about 7% fibrinogen, which we'll talk about, again, is going to be important in the function for clotting. So a couple really important proteins here that make up your blood plasma. And then in your blood plasma, you also have some other important smaller solutes, again, about 1.5%, that are again important as well. So things like electrolytes and nutrients, dissolved gases. There's some regulatory substances that you're going to find in there, like hormones, and then waste products. So those are all things that you can find inside your plasma. And then when you look at your formed elements, you can break down the formed elements even further as you break down your leukocytes. And we'll get into that in a little bit here, not to throw too much at you in one slide. So getting back to, and again, I kind of went over this, but here's the slide just getting back to the blood plasma. So again, about 91.5% water. It makes up your blood plasma. Again, plasma is, just this section here, that kind of almost yellowish transparent section here. And about 7% is the plasma proteins. They are created in the liver, but these proteins are confined to the bloodstream. So they are plasma proteins, and they're going to stay in the bloodstream. So albumins, again, they're important for maintaining your blood osmotic pressure, so that they're ensuring that basically your blood doesn't lose too much of its water and it doesn't keep too much of its water. And then we also have globulins, or immunoglobulins, and we'll talk about those in terms of, especially in the immune system. We talk about antibodies, and as you probably well know, your antibodies are something that's talked about quite a bit right now with COVID, because we're talking about vaccines and the formation of those antibodies to the SARS-CoV-2 virus, which is the antigen. Well, there are certain things on its surface. You guys have probably also heard spike proteins. So spike proteins are one of the antigens that are targeted by some of the antibodies that we're making. So globulins, again, are very important in terms of talking about these immune functions, this immune function that blood will help be a part of. And then fibrinogen. So again, we talked about fibrinogen is very important for clotting, and we'll get into that in a lot more detail when we talk about blood clotting here towards the end of this section. And then, of course, the electrolytes, nutrients, hormones, gases, waste products make up a much smaller portion of the plasma, but still very important. Okay, so our three major cells that we're going to talk about as the formed elements of your blood. So your three major categories of cells are going to be, the first one, erythrocytes, more formally your red blood cells. or I'm sorry, more formally erythrocytes, red blood cells again. It's kind of our more general term, but you're going to hear in anatomy, we're going to use the more proper term, erythrocytes. So erythro meaning red, cyte meaning cell. So these are going to be your red blood cells. Leukocytes are going to be the second major group of cells. And leuko means white. Again, cyte means cell. So these are your white blood cells. And when you look at your white blood cells, again, we'll get into this a little bit later. I'm just going to introduce it now. You can break up your white blood cells into the granular leukocytes, which literally stain with these. When you stain them, you can see these little granules that they have inside. And your agranular leukocytes, which A means without. So these are the leukocytes without granules in them. And the granular leukocytes are going to be, there's three of them that we're going to talk about: neutrophils, basophils, and eosinophils. And I'll tell you some stories about eosinophils because I have a child with an eosinophilic disorder. So I'm very well versed with eosinophils. And then you have your agranular leukocytes, again, which are going to be things like your T cells and your B cells, which are T lymphocytes, B lymphocytes, and some natural killer cells, which are included in here. And then also monocytes are your other agranular leukocyte, and your monocytes end up becoming your macrophages. So you guys have probably heard the term macrophage. So those are going to be your leukocytes. And so again, we have erythrocytes, we have all these leukocytes here, and then of course the last one is these little cell fragments that we call platelets, or more formally, we call them thrombocytes. So there's your formed elements. Now let's talk a little bit more about hematocrits. And kind of just to go backwards a little bit here and talk about what your hematocrit is. So again, when we talk about your hematocrits, we're talking about what percentage of your formed elements you have. And so on average, or another better way might be to say that it's the percentage of your blood occupied by the cells, by the formed elements. And on average, when you look at a female, the female's normal range is about 38 to 46%. So if you were to do a hematocrit, again, on a female, usually you would have about 38 to 46% formed elements, or your cells, right? And this weighs out to an average of about 42%. Now, if you look at a male, males have a normal range of 40% to 54%, which weighs out to an average of about 46%. And you may say, well, that's strange. Why is it different? Why do men have a higher percentage of formed element, higher percentage of cells within their blood? And so there's a couple of reasons for this. So one of the main reasons is testosterone. And so testosterone is going to be present in much higher concentrations in males than it typically is in females, right? Females are going to have a lower testosterone to estrogen ratio. Males are going to have a higher because they're producing more testosterone. And this is important because testosterone stimulates the synthesis of a hormone called erythropoietin. And I have to figure out my pen here. Let me see if I can figure out my pen. Oh, here we go. I don't want a red color. Let's try white. So testosterone is important because it's going to stimulate. This is my symbol. Sorry, I'm going to use some of my old note-taking skills here for stimulates. So that's a nice shorthand for those of you that like shorthand. That's a nice shorthand for stimulates. So, and it actually stimulates the synthesis of this very important hormone called erythropoietin. So, or I'm going to put EPO for short. EPO stands for, oh, I'm horrible at writing with these, erythropoietin, if you can see this here. Oh, I'm gonna apologize now because I am horrible at writing with these. I need to get a new method to doing so. Okay, so anyway, and it's EPO for short, so I'll use EPO for short coming up here. And that erythropoietin is the hormone that in turn stimulates red blood cell production. So EPO is going to stimulate RBCs. We'll just put RBCs for short here, red blood cells, okay? So, hence the reason why men have a higher number of formed elements, because men are going to produce more red blood cells. They have more testosterone. They're going to stimulate, that's going to stimulate more of the production of erythropoietin, and it'll stimulate more red blood cell production. So technically the testosterone is what contributes to the higher hematocrits in males. So that testosterone gives males that higher hematocrit. Okay, so let's see. Oh, now I just have to figure out how to get back here. Sorry, I'm still working out the kinks here to get. Okay, so there we go. So now we can talk a little bit about some of the challenges, the changes to your hematocrit from homeostasis, right? So one of the things is anemia. So anemia occurs when you don't have enough red blood cells. So anemia is when you have a low hematocrit. And sometimes it could just be that you don't have enough hemoglobin as well. But again, if you don't have enough of those red blood cells or even hemoglobin, then you're not able to transport as much oxygen. So hence that's why anemia is important. And then the opposite of that is polycythemia. So poly meaning many, so too many. Polycythemia is too many red blood cells. And this is when you have a hematocrit of something like over 65%. So that's a pretty, they don't really technically call you, determine you as polycythemia unless you have a hematocrit over 65%, which is pretty high. So this can occur for a couple of reasons. This might happen because you're really dehydrated. And so if you're really dehydrated, then you simply just don't have as much water, right? Because most of your plasma is water. So you simply just don't have as much water and as much plasma. So that's one of the ways that you can end up with a really high hematocrit, is just not enough water. Tissue hypoxia. So this can happen sometimes when you're at higher elevations. So maybe you're up in Flagstaff and you're doing some training, the higher elevations there, and just being up at that higher elevation with less oxygen will actually stimulate the production of red blood cells. Hence, this is why, a lot of the teams go up and train up in Flagstaff. And it gradually happens over a few weeks. And it's kind of a natural way to do blood doping. And then we'll get into the actual blood doping, the non-natural way here in athletes. So those all can cause, polycythemia, which is a hematocrit that's too high. Now, blood doping is where you're injecting previously stored red blood cells before an athletic event. So let me kind of show you how this works real quick. I'll come back to this. So if you're doing blood doping, what you're going to do is, over a month before, more than a month before your big events, you're going to go ahead and you're going to pull out some of your blood. You're going to go ahead and separate out those formed elements, store them in a solution that will keep those cells from deteriorating, from breaking down, and keep them at a colder temperatures until and again, you need to do this if you were doing blood doping. These athletes would do this like obviously a month, more than a month prior to their event, because what they want to do is they want to take up those blood cells, but then they want to replenish those blood cells. So over the next month, they'll replenish those blood cells that they lost, that they had pulled out. And then right before the event, they're going to go ahead and take those red blood cells and then inject them back into their bloodstream, giving themselves a extra advantage by giving themselves extra red blood cells. So that's what blood doping is injecting previously stored red blood cells before an athletic event. And this is, of course, cheating because you know, more blood cells, red blood cells, you have the better availability you have to deliver oxygen to your tissues. So more cells that you have now, you know, the better your delivery system is for bringing oxygen to your tissues. And this can be, one, dangerous because it's going to increase your blood viscosity, right? So it's going to make literally your blood thicker, and this can cause issues, including things like clotting issues, formations of clots, and it can also force the heart to work harder. So it's an extra burden on the heart. So not only is it dangerous, but of course it's banned by the Olympic Committee because it's you know, technically cheating. So and this was kind of interesting because I was wondering in the Olympics, my husband and I were watching the Olympics, and we kept seeing, instead of Russia, it was ROC, which is the Russian Olympic Committee. And we kept wondering, why don't they have anything that has like the Russian flags or, you know, on their uniforms or anything like that? They just had these very plain uniforms that had ROC on them. And I ended up looking back, and it was because Russia was banned by the Olympic Committee because of previous issues with blood doping. So again, just kind of interesting information for you since the Olympics were just here. So that is the skinny on blood doping. Always interesting to talk about some of these ways in which anatomy kind of applies to so much of anatomy applies to our day-to-day life, which is what I think makes anatomy a fascinating subject for anybody, but even more so if you're interested in the health profession. So we're going to stop here with formation of blood cells and getting into hematopoiesis, because it's just kind of a good spot. But we'll talk about, just really quickly before I end, that what we're going to get into in the next lecture is the fact that blood cells do die and we have to make new blood cells. So we're going to talk about that whole process, and it's a pretty awesome process. So I will see you all next time.